If we have a homomorphism between two groups, the homomorphic image of a subgroup of the domain group is a subgroup of the codomain group. More formally, if G, H, and K are groups, and F from G to H is a homomorphism, and K is a subgroup of G, then the range of this subgroup K under the homomorphism F is going to be a subgroup of the codomain group H. This is a basic property of homomorphisms. It's quite easy to prove, so give it a try yourself. I'll show you how to do it now. We begin by taking two arbitrary elements, f of x and f of y, from the range f of k. Remember, f of k is just the set of all values f of x, where x comes from that subgroup k. First, we need to show that this set is closed. So if we take these arbitrary elements and compose them, we will get something that's also in f of k. Now, if f of x and f of y are in f of k, then by definition, x and y must come from the subgroup k. But since k is a subgroup, that means the product xy is also an element of k. Then, f of x times f of y, since f is a homomorphism, is the same as f of xy. But we know that f of xy is an element of the range f of k because xy is an element of k. So indeed, the range f of k is closed with respect to the group operation. The group operation in this case being that of h, since f of k is a subset of h. Now that we know it's closed with respect to products, we need only show that it's closed with respect to inverses, which is straightforward. We know that the inverse of any element f of x is also in the range f of k because x inverse has to be an element of k. Again, k is a subgroup, so x being in k implies that x inverse is in k. But then, it's a basic property of homomorphisms, link in the description to the lesson where we prove it, that f of x inverse is the inverse of f of x. Homomorphisms map inverses to inverses. So since x inverse is in k, f of x inverse is in f of k, and f of x inverse we know is the inverse element of f of x. Since f of x is closed with respect to products and inverses, we've established that it is a subgroup of the codomain group H. Let me know in the comments if you have any questions, and check out my abstract algebra course and abstract algebra exercises playlists in the description for more. Thanks for watching.
Integrity, I'm a secular and aesthetic from my own effort.